objective. So we're going to look at continental drift. When the Earth was very young, the arrangement of continents looked something quite different to what it is now. So we called this supercontinent Pangaea, and there were a lot of animals. This is about 225 million years ago, and a lot of before that. Obviously, if you didn't have animals on land, and you didn't have lots of things getting fossilized, you wouldn't have much evidence. The rocks would give us some evidence as to where things went pre-Pangaea, but this is a fairly early part in the life of plants and animals. So continental drift looks a little bit like this. So we can see the continents spreading out, and this is happening over millions of years. Because it happened so slowly, it's one of the reasons why it took scientists so long to take these ideas on board. Scientists think the map of the world consists of one supercontinent called Pangaea, as we mentioned, and over the course of the Earth's history, the continents have drifted apart from their current position. So we can see here that continental drift occurred from the evidence that we have occurs from about 225 million years ago, 150 million years ago. So we can see this supercontinent Pangaea, and then we've got Africa and South America, we've got North America, we've got Europe and Asia. And so this then turned into Laurasia and Gondwana land about 150 million years ago. So these are still very close together. Look, South America and Africa, very, very close together by comparison to how they are now, and they are moving further and further away from each other. India and Africa around here. Now, what you don't need to know is where stuff was, but you need to have an appreciation of what things look like. So you can just look at the distances between the different land masses to tell where things are. So Alfred Wegner was the first scientist to suggest the idea of continental drift in 1914. Wegner thought that all the continents were once joined together, but had drifted apart over the course of Earth's history to their current position. So some evidence. Now, there are three pieces of evidence you need to be able to quote for the exams, and you could have a 3 or a 6 mark question. But the continental shapes, if you go back to this image here, you can see that they fit together. Did they ever fit together? Yeah, absolutely they did. It's weird that they look similar shapes because they did. But more importantly than that, and I mentioned this earlier, was about the rock shapes. We'll come to that in a second. We've also got fossils as well. So fossils, if you're not clued up on that, are animals or plants that have been covered over by something which prevents them from fully decaying. There are bacteria and fungi and all sorts of microbes and actually macroorganisms as well, so like carnivores, that will get rid of the remains. But if they fall into something like a peat bog, there's not much oxygen, and so they may be preserved and then squeezed and essentially calcified, turned into rock, so that we can then dig them up. Now, where the animals are similar, where we find these fossil, similar sorts of depth, being fossilized in 2 different continents, there must have been a